Okay, now for the area of surface generated about the y-axis given, y is equal to 2x between x equals 0 and x equals 2. Okay, now we're going to look at this from the perspective of integrating with respect to x. Okay, so just a little projection here. Okay, with respect to the y-axis. So again, we still have y is equal to 2x. And now we're not going to be looking at the height as was the case with the volume and the method of shells, but I just want to mention that we have for the projected radius. Okay, so you have p of x is going to be equal to x. Now, and we're back to the limits of integration where we have going from x equals 0 to x is equal to 2. So we have, in the case of setting up, what we have here. So we have for the area of surface generated about the y-axis. And if we put this in the context of integrating with respect to x, so we're going from x is equal to a to x is equal to b. And now we have 2 pi times p of x. And we have times the square root of 1 plus the square of the derivative, dy over dx. And again, so I have y is equal to 2x, and a little history repeating itself. So I have dy over dx is equal to 2, and the square of the derivative is going to be a 4. Okay. So just filling in the values. Once again, we have the limits of integration. Okay, so I'm going from x equal to 0 to x is equal to 2. And once again, we have p of x is equal to x. So I have 2 pi times x. And I have times, okay, the square root of 1 plus 4 dx. I have going from 0 to 2. So I have 2 pi x. And I have times, okay, the square root of 5 dx. And for the antiderivative of 2 pi x would be pi x squared. And we have, tagging along, we have the square root of 5. And we have as x goes from 0 to 2. Okay, so at 0, the expression is negligible. As for 2, we have 2 squared is 4 times pi times the square root of 5. And once again, we have for the area of surface generated about the y-axis. And again, we will end up with 4 pi times the square root of 5 square units.